Welcome, everyone. This is Graham Warren, welcoming you to the AI/ML annual mini conference. We are fortunate to have Abirami Sukumaran today. She is a Google advocate in cloud and journey to AI. She comes to us as a published author. I've got a copy of her book here. I want to put in a plug for that. And I'll pass this around so you can have a look at it as Abby speaks. And Abby, I just want to know, can we ask questions as we go, or would you like us to wait until the end of the talk?
We can ask questions as we go. I'll try to pace it, maybe one or two questions, and then we'll keep moving with the topic.
Appreciate it. I'm just going to pass your book around. Thank you so much. And I've posted your bio so everybody can see that. Really appreciate you talking with us today. Thanks.
Thank you for the introduction. Thanks, Graham. Thanks for sharing the book as well. Hi, everybody. Good evening. Good morning. I know it's morning over there. And I'm really excited too. Graham, can I get started?
Yes, sure thing. Please. Yeah. You can share your screen if you need to.
Okay. Yeah, let me do that. Okay. I've shared my screen now.
I think I need to stop sharing. Okay,
Oh.
yes, we can see it now. Yes.
Cool. Thanks, Graham. Thanks, everybody, for joining today. And I'm really excited to walk you through overview level at an overview level for some of the topics that are very close to my heart. Usually, I'm a developer advocate, and usually I focus predominantly on Google Cloud databases, generally any database in general. But now I work a lot on Google databases that are on cloud and building applications that are useful or that are useful for all data management activities, data governance activities, and in some cases, natural language, predictive, so on and so forth. But now generative AI has become the one thing that all businesses focus on, all startups, all organizations. So it is the main point of focus for learners, for developers, for products as well, and for companies. So yeah, building applications in the data to AI area, moving data to AI, or bringing generative AI closer to your data has always been or at least let me put it this way, I at least encourage organizations and startups to bring AI closer to data than the other way around. Because for long time, we've been thinking of AI as a separate entity, which only data scientists and other data analysts or data analytics folks focus on. And the application development was reserved for folks who are in the engineering arena or in the engineering area of technology. But now there is a huge overlap with the advent of generative AI. Some of those things are what we're going to see today. But for the most part, we'll talk about, of course, the basics. I'll show you a flavor of what Vertex AI looks like and where you can find things with respect to generative AI in Vertex AI. And prompt management, as simple as it may sound, there are some pretty intriguing ideas in here. I mean, I'm not particularly those are not exclusively my ideas, but these are collective. These are some thoughts as well. This is not a solution or a cookie cutter solution for all of prompt management problems, but these are ways or ideas that one can address their production applications, or how to do prompt management in a production application, right? So an approach for that is as if you can think of this as a proposal for prompt management for applications in production. So we'll take a look at that, and we will also talk about model tuning. We'll talk a little bit about model evaluation. I'll also walk you through a few code snippets here and there, so you can get a feel for the hands-on part as well, and you You will see how easy it is to take a foundation model and then do a bunch of code snippets on top of that to do model tuning, model evaluation. So you can compare the one that you have tuned versus the one that's available in foundation, and you can determine which one you want to go with for your production application. Again, we'll also see some operational topics like model monitoring, and most importantly, my most favorite topic of all time, which is data integrations, which is enterprise data integrations. Of course, AI, ML data, all of these things are important for businesses to run their day-to-day activities, or also for even products to be complete. We need these integrations, but most importantly, databases and how you can bring generative AI and AI applications closer to your data in situ, or what we call as in-place data integration. So we'll take a look at some of those aspects as well, hands-on. So those are the things we'll discuss today. Of course, here and there we'll have some jargon. If you feel that this is something that's totally new and this topic is or it's fast, please feel free to stop me, ask question here and there. But let's keep it to 1 or 2 questions during the flow. At the end of the session, I'm hoping to have at least 10-15 minutes to do a quick round of questions as well, Q&A as well. All right. Let's get started. For the overview, I'm sure you all know what large language models are. I don't have to start from the scratch, but just to revisit the basics, I would like to say that large language models have always been thought of as, because it has the word language in it, people tend to continuously think that, oh, it's only models that deal only with languages or text content. So the word language is pictured as text or text format of data in a lot of our minds. So what I would say is it's not necessarily like that. Any format of data, the way we communicate with the models or machines, the way we communicate with the machines or the models is what we call as language. So it could be text format data, it could be data in the form of images or videos. Of course, the kind or the variety or the variation of the model might differ, but ultimately, the generative AI model as a whole helps you perform some natural language activities, but in a larger scale. When I say scale, it's not just at the application end, but the scale also goes behind the scenes in the number of parameters that are used to tune these models, or the number of parameters based on which these models are tuned. So basically, why we call these as large language models, because they are pre-trained on petabyte scale text based data sets, resulting in large models with tens of hundreds of billions of parameters, as you can see in bullet number 2 right there. So that is exactly why these are called large language models. These are pre-trained on large corpus, and this doesn't limit it only to text data. When you're applying it, you can apply it to any modality which the model supports. But of course, for each modality, you'll have a variation of the model itself that you will be putting into use. We'll also visit some of those when we are looking at the foundation models. Now, where did it all begin? Of course, it all dates back to transformers, but if we have to really look at the date back for data or database ever, you can also find those concepts in my book, where I talk about how everything started from, the time of, dates back to the time of Aisha or the time of monkeys, and how it all transformed into what we do as database right now, or what was once the basic calculator and all that. So it's a very interesting topic, but from there we've come a long way. Already we had come a long way with transformers, but now as of last year, with the advent of generative AI, which was everyone in the industry was talking about it. All developers wanted to ramp up or wanted to upskill in the area of generative AI. All companies wanted to do something in generative AI. Just having the name there in their use case was a big deal, and people even now, all companies and all startups that we work with, they want to have generative AI in some aspect in their business, but there are some limitations. They don't know how to transform some of the things that they have done traditionally with, let's say, a BERT algorithm or a BERT API for that matter. We would have used that in the past, right? We would have used BERT for summarizing text, but that was not necessarily called as generative AI back then, even though technically it is still generative AI. You would pass in a bunch of text and then ask the BERT algorithm to convert that into summary of 2 lines or 1 line. It still did the same thing. It's just that it was not pre-trained on such large scale data, and at the same time it was not applicable at this scale that it is available back then, and it was not, for lack of better word, I'm going to use the word advertised. It was not advertised the way it is right now for generative AI back then. So as you can see right here, it has been evolving throughout. Even though companies now, looping back into the point that I was trying to make before, companies now want to do a lot with generative AI. The point that they are missing is we have been doing that a lot even in the past. Anything with natural language, which we have traditionally used some APIs here and there, not knowing that they're actually generative AI behind the scenes, but not at the same scale. Now the need for transforming that into new APIs. So those things are there, and a lot of in a lot of cases, companies and startups face problems in building applications at the scale that they need, and also to differentiate between application development and data science, which traditionally data scientists used to do. And now there is like a small gap. I wouldn't say it's a big gap, it's a small gap between, oh, I want to do this, do I need to hire? That's what we're going to look at today, how to map that gap and how technology has simplified the process for us. So it's not so much of a burden, it's just in the understanding of how to put the best use of technology. So that's what we'll look at today. But just to walk through the journey, we've started from transformers, we've evolved over time to where we were last year. But now with Gemini, which is actually the last lab that's supposed to be there in 2024, it's not there in the slide for lack of space. But in 2024 we have Gemini. We have Gemini 1.0 Pro, we have Gemini 1.5 Pro, and then we have Gemini 1.0 Pro Vision as well, which is for multimodal. So we moved from language based transformers, and then we moved to language only, and then we moved to Bard, which was a conversational AI service that was built on top of the large language model. And now we have Gemini for everything. So we have Gemini for code assisting, Gemini for databases, which lives within the database tool, which we'll see right now. And then we have Gemini for building applications, and we have Gemini for overall technology questions, anything that you want to do on the Google Cloud platform itself, overarching all technologies. At the same time, it is context aware within the scope of your session. It is able to understand and answer and provide relevant code, and so on and so forth. And then we have 1.0 Pro Vision and 1.5 also, which are all multimodal, which means you can interact with, you can upload a video and ask interactive Q&A, and use other kind of retrieval augmented generation methods or other frameworks like LangChain and so on and so forth to build applications on your own. So this is a simple timeline view of how far we've come and how we are going in the future.
Abhi, could I
yes.
interrupt you here for a second? We're
Yes.
we're doing a machine learning class here, and all of our data sets are basically tabular, maybe with some text included. This multimodal Gemini versions that you've got, how do you how have your clients, or the target clients for Gemini, how have they evolved in their thinking about using multimodal data, putting video and tabular and all of that into a project? I mean, have you noticed that transition over the last, let's say, 3 or 4 years? Are clients becoming
Yes.
sophisticated in their thinking about multimodal?
So there is a good that's actually a good question, and also a good thought process as well to evaluate how they've adopted. So I see a big difference between organizations. When I say organizations, established organizations who have been doing enterprise applications for a while, and then startups. Startups have hopped on to this trend of multimodality in their applications quite a lot, and they want to use data of all formats and modalities together. And I'll come to that in a bit, like how to bring that both tabular data and make sense of that and do predictive analytics in that kind of a setup. Whereas organizations such as the ones who have a sophisticated software development team set up, and they have the entire ecosystem they have been building for a while, they are more comfortable with their tabular data, and the use case for them with say other media, multimedia, has not been that much as compared to startups. They are appreciating the value, they know that they could use it, they are like still evaluating, let me conduct hackathons and see how much more of use case I can get. So I see that big difference, but the shift is there, the eagerness, the interest to go forward is definitely there. But startups are way ahead of other established organizations in this case, to answer your question.
Thanks. Abhi,
Yeah.
I think you're sharing the video. Could you share your screen again, if you don't mind?
Yes.
Thanks.
Sorry. Cool. Yeah. So moving on to the first topic of our interest today, which is the prompt management. So prompt is anything that we ask the machine to do. So that is exactly how we differentiate ML, AI, and generative AI, right? With ML and AI, traditionally we have asked, or we have, rather than asking, we have taught the machine to do something. We have trained it on something. We've given it the data, we have given it the material, we've given it the training and everything that's required, and the math and everything behind the scenes for it to do something. So we'll teach the machine to do something, and then we'll ask the machine to do something. With AI, we'll teach the machine to do something, and we'll give some real world data. And on top of that, uh, provide some training data, and then ask the machine to do something. So with generative AI, the difference is that you don't necessarily have to do these things. You just have to ask the machine to do something, right? So that exactly is what we call as prompt, and the art and science of figuring out how to ask the right question so you get an answer in a structure and format and template that is acceptable for your business or your application is exactly why prompt design or prompt engineering is such a big deal right now. A few months ago, or at least 6 or 7, let me say 10 months ago, prompt engineering was like a huge was there everywhere. It's on job portals, and it was a huge deal. Even I was one of the people who thought at that time, why is it such a big deal? Like, I understand prompt engineering is important because business is overpowering. Like, of course, we want technology to drive business, right? It's not the other way around. So it's business that drives it. So as long as you know to ask the right question, it's a good thing. But why is it such a big deal? Why is there so much demand, and why is it such a highly paid position? And all the, why is there a separate position carved for it? Why can't a regular software engineer do it, was my question all along. But in a few seconds, in a few minutes, you'll see in the next few slides as to how important it is for a generative AI driven application in the entire ecosystem of software delivery, how important it is to maintain prompts, basically to maintain and manage and to engineer prompts, how important it is, and how what are the challenges that one would face, and how it continues to evolve. So that is something we'll see right now. Of course, these are some really basic information about prompts. You may probably already know it. If not, it's just like if you're just doing a prototype and not nothing, no production application, nothing. Just remember, zero shot prompt is one where you just ask the question like, why is the sky blue, or what is the color of this, so on and so forth. So without any example. So that's zero shot prompt. One shot prompt is where you provide one example, provide a structure of what the response would look like, or what the request would look like. So that is one shot. Few shot is where you provide a few examples of what the request and response would look like, give certain instructions, and ask the model to deliver it based on some of the examples that you provide. So those are three key categories of prompts. But this is of no significance if you are not actually for example, if you're not actually considering a proper prompt management strategy, this is of no significance, because it's like, okay, fine, I'll give example or I'll not give example. No, but why are we giving that example? What is the format? What is the structure? Are we going to productionize this? Are we going to version it? So those are the things we need to think about, which we'll discuss down the line. So these are some of the basic, very really basic topics that you would need to know, because when someone says it's like zero shot or one shot, we need to know why it's called that way. So that's why I thought it was important to call it out. Before moving to Vertex AI, the reason why I plugged this slide in between the topics that we're looking at today is everything that we are going to discuss today, or everything that we're going to see hands-on today, lives within this service called Vertex AI in Google Cloud. This is like a one-stop access for all of your ML, AI, and generative AI needs. So if you go to Model Garden, you can find all available foundation and open source models that are categorized by tasks, categorized by modality, categorized by areas of application and stuff like that. And also for whether it's foundation or depending on whether it's open source, it will be categorized according to that as well. And then you have Generative AI Studio, which you can just open up quickly, run a few prototypes, design prompts, see the results, fine tune even from the console. Basically, everything that you could do programmatically, or everything that you can do with Terraform scripts or stuff like that, or Python code, or just a few lines of lines of code in your notebook. You can also do the same things with Google Cloud Console. So this is like using point and click methods. Of course, it won't be like a productionized, fully pipelined solution, but of course, it is a good place to start, where you can use the console to do the regular generative AI activities, which do have their equivalent uh, programmable version as well, right? Their equivalent library versions as well, their equivalent client libraries, their equivalent API implementations. So you have all of these things, but generative AI Studio is where you can do it hands-on by point and click methods just on the console. You can do all of these things: prompt design, prompt tuning, fine tuning. You can also do grounding. You can do distillation, model distillation. You can also give reference material. So all these things you can do from generative AI Studio. So these are only from the generative AI perspective, but Model Garden also has some regular models that are not necessarily generative AI, models that are NLP based, models that are vision based, models that are AI driven. So all of those things, those traditional models are also available in Model Garden. And then the ML platform, Vertex AI has other things as well, not just generative AI, right? It supports the entire data science toolkit, everything that you need for building the end-to-end pipeline, end-to-end MLOps pipeline, and end-to-end feature parameter tuning, or everything that you want to do with machine learning, you can do within the scope of Vertex AI. Model deployments to endpoints, model registry, monitoring, everything that you need is available there. And also we'll see that in a bit. And also it is a place where, like I said, where you can use a generative AI Studio to run some prototypes and all, but at the same time you can also view the equivalent code for it right there, which you can copy paste and build on top of that. So what I'm trying to say is you basically have a starting point for anything that you want to do with respect to ML AI and generative AI in Vertex AI. So before moving on to that, let me just show you what it looks like. I'm sure there are some folks, or most of you would have already seen Vertex AI. If not, just go to console.cloud.google.com. And on the search bar, you can search for Vertex AI. Click on the Vertex AI One AI platform link, and then you'll land on this page. Like you can see here, I'll show you what Model Garden looks like, because it's really important to see all the models that are available for you to choose from. So this is what Model Garden looks like. It's loading for me, one sec. Yeah. So as you can see here, it lists all the models available and it categorizes them based on modality. What are the language models available? What are the vision models, tabular, document, speech, video, and based on tasks also it is categorized. Generation activities, like what kind of, whether you want to do text generation, and what kind of, so it says there are 57 models for generation tasks. So let's see what they are, right? So click that and you can probably see. Is it filtered already? Okay.
I mean, could you show us the classification models
right.
for a second?
Yeah, classification. There we go. I'll remove the generation one, just the classification. There we go.
Okay, cool.
There's image, all types of modalities, right? We have not filtered by text, but if you want, we can filter by text also. Like you said, tabular, right? So let's take tabular. So these are your options available. What are the foundation models, and what are the fine-tunable models you have, which means you can use this model, but at the same time, you can tune it for your use case. And then you have TabNet, AutoML, E2E. So AutoML is also available from within Vertex AI. So these are some of the models that we have right here. Yeah, so like I said, it's also categorized by features, whether it's these support are available for these models or not, whether it's available for one-click deployment or not. And then let's see, if you, let's say you want to use 1.0 Pro or 1.5 Pro, you can just click that and go to the corresponding model right here, right? Open in Vertex AI Studio. So there we go. So you can provide a prompt. You can actually provide instructions here, even though it says optional. This is what we'll look at right now. You can provide a prompt right here, and then you can choose, again, you have the option to change the model from here as well. You choose your region. Usually US Central 1 works just fine. If you want to control the wildness or the randomness of the response, use temperature. The lower the temperature, the more precise the result. Precise is probably not the right word to use. It's less creative or less wild. The more the temperature is, more creative the response. And then output token limit, how many tokens you want in response. And then you have advanced parameters like top P, top K, max responses, like how many responses you want from the model. Top K determines how many so how you would like your response to be picked from the available tokens. For example, if you set a top k of 20 or 30, it'll pick your next possible token from the top 20 best tokens that is available next. So that's what top k is. And similarly, top p is the probability, like how probable are your tokens to be picked as the next possible token. Like as we are speaking, we are choosing words, right? We're thinking about I want to talk about a model that is let's say a tabular, or I want to use the word multimodal instead, or instead of tabular I want to use rows and columns, right? So as you're speaking, your brain is capable of choosing one word over the other. I want to choose the word tabular instead of saying rows and columns because it's more it's more acceptable. Everyone understands when I say tabular. Whereas I say rows and columns, you instantly think of a spreadsheet or something similar, right? So you don't want to confuse, so your brain chooses tabular. Similarly, top P allows the model to pick the token that is more suited as a response. So those are those advanced parameters. Usually, you can always use these and change these to impact your response. Sometimes trial and error works. That's why you go to this particular studio, Vertex AI Studio. You run your prototypes. You make sure this is the temperature you want your response. You want your parameters to be configured in. This is the top K value you want to set. This is top P value you want to set based on your prototypes, and then you productionize this application. Start writing code using this. And how will you get code? You can always click on the get code part here and get the foundational code for it, and then build on top of it. You just copy paste this, or directly open notebook from here. Or if you're writing this code in another programming language like Node.js or Java, you can always copy paste from it. If you want to test it, if everything works and your authentication and everything works just fine, just copy the curl command, run it from Cloud Shell terminal, which lets you get the response then and there itself.
I mean, would
Right.
it be possible to work through just a simple example for us, just showing us, what your thoughts are would be for P and temperature and so forth?
Certainly, yeah. Let's say I want to use Gemini 102 Pro. Okay. Say I want to choose 5. Plus just a random question. How do I make coffee? So currently my output token, and so temperature is set at 0.4, and your advanced settings, max response is just set as 1, and top K, let's set it as 8, and top P, .5, right? And I have not given any, if you notice, I have not given any example. There's no one shot or few shot prompt. It is just a blank question, 0 shot prompt. How do I make coffee? This is a random example we've got, and I've just changed the parameters, and let's see what the response looks like for that case. I'll reduce the temperature even further. So without giving any of those settings, for the default settings, this is the response we've got. Materials needed, instructions, and then probably tips, additional notes. It's a big answer. It's a good answer though. I mean, we have everything that we need. Now let's say I want to ask the same question with all these parameters in place. And reduce the output token limit.
One of the things that I'm hearing is a lot of folks like almost 0 temperatures. What is your experience with that, in your conversations with a lot of users?
Can you repeat the question about the temperature? That part
Yeah,
I missed.
a lot of folks just insist they want to use a temperature very close to 0.
Yeah.
What are your thoughts about that?
So there are two ways to address it. I would say it's okay to go up to a 0.5 or 0.4, but use RAG for your use cases, right? When I say RAG, some of the models, when you're doing it programmatically, you have the ability to factually ground models' responses, which means you provide information based on which you can ask the model to pick responses. So I'll say something like this: how do I make coffee? Use the resources available in this PDF. Make sure maybe the PDF has, it's an entire recipe book, right? It also has how to make coffee. I just don't know where it is. I don't want to just keep flipping or something like that. So you ask it to reference a particular PDF or something like that, and then get your response from there. So if you're doing it RAG method, I will say 0.5 is still okay. But if you don't have any resource at all, there's no context to begin with, and it's an open-ended question, then keep the temperature as minimal as you want, because so that it's not very creative with the responses. Because as much as advanced LLMs and generative AI models are getting, even though they are getting very advanced, even though they are giving us precise answers, it can still hallucinate. Even though the word hallucinating is not very common these days as it was at least 10 months ago. The reason is we have started using RAG. So people want to avoid hallucination. People want to use, businesses want to use more than, some guesstimate answers, or people don't want to basically use open-ended questions. They use things like function calling. They want to use traditional programming as an augmentation over generative AI itself. So businesses don't use open-ended questions unless it is a really impossible situation where you have no such information. There is a chatbot where you can't limit them with rules, but there are like 10,000 different variations you possibly have as context, but still somebody is coming and entering a 10,001 area of question which is not covered in your context. Then yes, it might be wild, it might be creative, but yeah, it's okay to have the temperature as low as you want if the question is open-ended like ours.
Thanks.
Sure. So let's just finish this. Okay. All right. If you see here, I have not truncated, I've limited the output limit to a token limit to 100, right? As you can see here, it has just cut off the response. It has given the same materials, it has given the instructions and everything, but then it has stopped the response because I've cut the output token limit. But of course, that's not the best approach. You don't want to limit the token. The way you want to approach it, if you want the answer to be of smaller size or smaller length, is to give one short prompt or few short prompts where you say, this is what I want my output to be structured like. And you can actually provide the structure, which is what we are getting at the next slide of discussion. Let's get to that. So I'll show you what good prompt engineering is, and what are the steps we need to take, what are the things we need to address, and eventually I'll also show you a sample prompt template which can be productionized for some result evaluation use cases, which I know was of interest to Graham as well at one point. So let's take a look at that. Right. So why is prompt management important? It's not only new for generative AI, right? All of our application development or software delivery areas in the past have focused on operations, which we fondly call as DevOps. We also there are other names. It's called SRE, site reliability. There are different variations of it. There are different names for it, but ultimately it's all operational activities, maintenance activities, management activities, right? So any pipeline requires it. So generative AI or LLMs are not an exception. We need governance, traceability, repeatability, and monitoring for these applications as well. Governance is important because we need to know how wild or how different a new upcoming question is from what you thought originally. Like I said, we covered 10,000 scenarios as part of context, thinking that the user will ask questions from one of these areas, because that's what we know as far as the business is concerned for the last 10 years. Just for example, I'm saying, let's say my business is 10 years old and I have information, let's say a context which covers 10,000 different areas. When I say areas, some areas are related to my, say, production support for my business. But now there is an entirely new concept that's coming in as part of a question, which is not covered in any of those 10,000 contexts that I've provisioned as RAG context or RAG baseline for my model or for my application. So now the model does not know where to pick the answer from. It gets creative and provides response. So that is why governance is needed, because from that point onwards, we want our application to feed back the new information that we've got, pipeline it back to the system, and say that, hey, there's new information. How do you want to process it? Do you want your analytics team or your business team or your analysts to sit and work on that and bring in new data to give or fine tune existing models to train on this particular information, or do you want to just tell the user that this is not covered? This kind of information, these areas are not covered as part of our chatbot or something like that, right? So that's why we need governance, because it's not a one-time thing. We are going to, once you build the application, once you do prompt management to build your chatbot or to build your Q&A system or to build your summarization system, it's going to be used for different purposes. Data, of course, keeps evolving with time. Questions keep evolving with time. That's why governance is all the more important. You would be very familiar with it, given that you're all in the data area or applied data science areas, right? So again, traceability, that is also important. Repeatability, like I said before, we want to be able to repeat it for every area. We want to be able to repeat, or that's what we call the end-to-end pipeline. And then monitoring, we want to see how the model or the prompts are performing. So prompt monitoring is also important. So one main thing, the difference between a traditional predictive AI ML pipeline and the prompt driven large language model or generative AI pipeline. So if you have to take a guess, what would you say is the difference, the main difference between it's the clue is probably very much in the slide itself. It's there in the bottom right corner. I have some text so that I use the I don't miss out on the key points. So I just added some text over there in case you want to reference that. But what do you think is a key differentiator between a standard, apart from what LLM and AI, how AI, ML and LLM differ from each other? What is another key differentiator which could be considered as a problem or an opportunity or a challenge between these two pipelines? Anyone wants to take a guess?
I don't think we need to understand the question a little better.
Okay. So what I'm saying is a standard AI ML pipeline. When you set up the training data, you set up the entire production pipeline with respect to training, additional artifacts, model provisioning, model serving, and then serving it as an endpoint. So this is a traditional AI ML pipeline. There we give training data, we have data sets, we have parameter tuning, and then there is the generative AI pipeline, which looks like this, which only has prompts and how the prompts are evolving and how it's being applied, like probably prompt deployment and so on and so forth. So between the two pipelines, what would you think is what is the main problem statement? Like, how does generative AI differ from a standard AI ML pipeline when it comes to data and schema handling, or let's say operations?
I don't think we're going to have an answer to that in the room.
Okay. No worries. No. Yeah, it's there are a lot. So let me tell you, the reason why there is not a single answer, correct answer to that, is because there are a lot of reasons. They are different. So I understand it's a little gray. There's no black and white answer. But one important concern that I think from an operational perspective or from a maintenance or governance perspective is that with the traditional AI ML pipelines, we have a clear delineation between data and schema. When we say data and schema, the validation between production and training data sets, and also between the data and schema itself, there is a clear delineation. When we say schema, it is about our model registry, ML metadata, parameter fine-tuning, hyperparameter tuning. So those kind of configuration or schema level elements are separate from the data itself, which contains just the training data set, versioning of training data set, the drift and skew between the training, the data and the parameters that we have, so on and so forth. So basically the data and the pipeline, or what we call the schema, are clearly separate from each other in a traditional predictive AI ML pipeline. Agreed?
Sure.
Right? But in a generative AI pipeline, both our data and the pipeline, or what we call the schema, they are both prompts, right? You don't have anything else. You have prompts. You have prompts that are data. You have prompts that are schema. So how can a prompt be a schema as well as data? Should be the question that you'd be having at this point. We'll come to that in a bit. When you see the template, you'll understand, or the sample template, you would understand how it's different from how we have both prompt as schema and prompt as data in a bit. So let's get to that before we come back to it as a problem statement. Here we go. So this is a slide that shows prompts as code and pipeline, and prompts as data. So when we say pipeline or schema or code, we will use prompts to act as context, to act as guardrail, to act as few shot. Remember the few shot example that I gave you before, like what is no shot prompt, zero shot prompt, one shot prompt, and few shot prompts. So the examples that you provide are not your actual data. The examples that you provide are artifacts. These are the schema. These are what we call as code. These are, so since we looked at it from an example perspective on the Vertex AI console, you probably did not see the difference, because what I gave here is how do I make coffee? But let's say if I gave an example, this is what my request will look like, but I want my response to have 5 bullet points. The first bullet point will have ingredients. The second bullet point will have step 1, step 2, step 3, and the last bullet point will have a summary. That's all I want you to respond with. So if I give a formula like this, then the response will be entirely different. You can play around with this. I'll give you the links and other details that you will need for it in the end of the session. But so this particular template which I told you right now is not data. This is formula, or what we call a schema. When you think of prompt management as an application, or when you're trying to achieve it programmatically for your production application, this will go in as an artifact. It will not go as data. Why? Because when you're designing the application, you will write this part of prompt as well in your application itself. So it becomes your guardrail prompt. It becomes a prompt template. Whereas the actual the user input data itself, like the question that gets replaced every single time. So I can ask this question in multiple ways. How do I make coffee? Or what do I need to do if I want coffee? Or I feel like having coffee, what should I do now? Or how do I get coffee here in this? Or where do I get, what is the nearest place to get coffee? Whatever is a question, there are the same, your chatbot or your Q&A application can interpret it in this way, that it relates it to the same question, it relates it to the same prompt template or formula that we have provisioned, and it will give you the answer, or give your user the answer that you have designed, in the format that you have designed, not the answer, but the format that you have designed. So this is exactly the difference between prompt as code and prompt as data. The reason I took a little extra time here is because this is exactly what you need to understand when you're productionizing prompt management in your applications, right? So now going back to understanding what is the main difference is, we don't have such a thing in the traditional AI ML world, because data and schema are two different things. Pipeline and data are two different things. Whereas here, pipeline and data are both prompts. So the main challenge is the distinction between data artifacts and pipeline artifacts is highly overlapped, because prompt itself is code and prompt itself is pipeline artifacts. Now, the second difference is, because prompt is both data and pipeline, feature distribution is really different and really complex. We can say it as complex, or it requires a lot of innovation for us to be able to understand feature distribution in a generative AI world as compared to the traditional AI ML world. Because in a traditional AI ML world, this is what your feature distribution looks like. Let me show you that. Yeah. On the left, you see the structured, tabular, categorical, and numerical data. You can say that, okay, it's skewed a little bit. I expected it to be, let's say, between 1 and 10, but now there is an outlier. It's 200. It's an outlier or something like that. You can just visualize it. You can understand the skew and the drift in data just by distributing the features, just by visualizing it in graphs and charts and so on and so forth. This is your traditional AI ML on the left-hand side. On the right, in the generative AI area, look at prompt number 1. Can you help me plan a tropical vacation for a family of 4? And look at prompt number 2, the bottom one, which is, what do we need for a trip to Hawaii? These two could be related, because the chat application that you're building for travel could include these two. You're not including anything. It's a travel and vacation chatbot for some company. Now your user can ask questions of type 1, or eventually they can progress to ask questions of type 2 as well. So how will you represent the skew here? How will you represent the drift here? Right? Ultimately, these two questions can get the same answer, but one particularly talks about Hawaii or specific location, or ask questions about what do I need, just like I said for the coffee example, right? How do I make coffee, or I feel like having coffee, what do I do? These two are same questions, but one has specifics to I need to plan a tropical vacation. The other one has specifics to a particular location. So how do we calculate? How do we catch the drift? How do we catch the skew? And how do we visualize it? So this is another challenge. So these are the two important challenges when it comes to generative AI as opposed to the traditional AI/ML world. So this is one of the key scenarios where businesses and startups have problems in understanding or productionizing this application, or they have not. If they are not aware of this, probably they are not yet there, right? They have built the application. They are very happy with their generative AI results. Yes, but eventually over time, the whole point of the pipeline that we are talking about has to be thought through. So one suggestion to one approach to this is mapping prompts to embeddings. So if you imagine, this is where embeddings come into play. So what you all probably already know what embeddings are, or what is embeddings. Embedding is a numerical or a vector representation of data, any format of data. It could be text, it could be image or video. In this case, our prompt is a text. So embeddings would be a vector or numerical representation of this text. So that's what embeddings is. And why exactly do we need to convert text into embeddings? Because we want to be able to search fast, and we want to be able to search in the perspective of context rather than by keywords, right? We don't want to do keyword matching. Of course, if it matches, it's a happy occurrence, but we also want it to be context based. I want my meaning to be related to what is there in the database. So we want to do a meaning based search, or meaning based correlation, or meaning based nearest neighbor search results, rather than having just keyword based, right? So that's exactly. And also for fast searches, for efficient searches, we want to convert our data into embeddings. So one solution is to convert map your prompts or map your prompts to embeddings, and by doing so, you can cluster your embeddings and see how closer or farther away your most recent prompt is from what you originally planned for your application. So that will catch the drift. That will tell you whether your most recent application or your user request has aligned to what you thought would be your prompt's use case, or they have moved further away from it and it has a new outlier now and you have to plan for it now, right? So that is how you can, one way to approach this is converting your prompts to embeddings and find how far or close to your foundational prompt, or your original V1 prompt, how close or far away from your V1 prompt is your user request, is something that you can identify by converting your prompts to embeddings. Right? That's one way to handle it. What's the second way? This is our conventional NLP way, where you take the user prompt, you break it up into entities and complexities and group them. For example, word cloud, right? How you used to do word cloud in a typical NLP world. So form a word cloud and see how close it aligns to some of the word clouds you already have in your prompt pipeline or baseline or prompt code. Now see the distance between the two and see how far your application has evolved, or how far your users have evolved from what you originally thought they were, or how far your data has evolved, so you can plan for it further. So this is exactly how prompt management can be. There are several ways you can come up with your own creative approach to this as well, but these two are something you can get started with when you're productionizing prompt management in a production grade application. So I spent a lot of time here. I just want to quickly talk about fine tuning as well, fine tuning and evaluation and data. These three topics, I'll probably take 5 minutes each, if that is still okay, Graham.
That works. Yep. Thanks.
Okay. So moving on, again, this is just how to choose your approach between embeddings based and semantic. Choose the one that is applicable to your application, whether you want to be mathematically rigorous or your application is mathematically rigorous, go for embedding based. Make sure your use case is so a semantic base is very specific to the business application that you're trying to solve the prompt management problem for, right? So make sure which side your problem falls under, and choose the right approach for prompt management in your case. Again, prompt design, prompt management best practices are available. This is one resource. If you want, you can just scan this and read some more of this information. All right, model tuning. So model tuning, like I said, like we talked about model tuning a little bit in the first part, which is the prompt tuning part. Prompt management, prompt tuning part as well. I just spoke a little bit about model tuning and why it might be required. I'll just reiterate that now. So not always you will want to use the foundation model as it is, right? Let's say we'll see an example in a bit. So it takes information that's available in, so let's say there is a news channel that wants to summarize news, right? That wants to find out headlines for news, auto generate headlines for news. Now there is bunch of news that the editorial team and the reporters have created, but we want to generate headlines that is suitable for that particular chunk of text that's created. Now, the model that the foundation model that you're planning to use will be able to provide a generic headline for it, but is that in line with the tone and the voice of that specific news channel? That is something that you can't guarantee, right? It may go with what's best for the trend. It may go with the headline that's best in LinkedIn or Twitter or whatever is the trend today. It might go with that, or whatever you whatever the model was trained on originally is what it'll understand. It'll provide us headline, but that might not be what your business wants. In which case, assume that you're a news channel and you have a certain style and format of providing headlines. Then you cannot always guarantee that that is the format you will get the result or headline generated in. Why? Because you did not instruct the model to do it that way. But let's say you choose to instruct the model to do it that way. That is what we call as fine tuning. How do you choose to instruct the model to behave in a certain way? It's very simple. You already know the answer. You already have done it in your NLP, or sorry, in your ML AI world, where you train it based on data. Right? So one approach is to do supervised training, where you provide training data. In this case, you will provide JSON-L file, which has a bunch of requests, which are prompts, and responses, which are prompt response from the model itself. So you'll give this, you can have 100,000, 10,000, 200,000, how much ever data you have. Feel free to train the model. It's a few lines of code if you're doing it programmatically, or if you think it's a one-time activity, let me just do point and click and do it through the console. You can also do it that way. We'll see both in a bit. But before that, I forgot that I told you I'll show, which is really important. Let me just quickly show you that as well before I move on. The reason I forgot that is because it's in full screen share mode, the presentation mode, and I had the prompt template open in another tab here. Okay, it's there in a GitHub repository. It's linked in the deck. I'll also share the slide deck with Graham after the session. So probably you'll all be able to access this repository and get a hold of this template as well. So don't worry about taking a picture or anything right now. You'll get this deck at the end of the session. So as you can see right here, this is a sample prompt template which I've provided. You can assign a role. You don't have to put these headers in the template, in the prompt. You just say, you're instructing the model. In this case, let's say I'm using Gemini 1.0 Pro. I'm telling that Gemini, you are in a panel of judges assessing ideas for hackathon centered around the theme of innovation, blah, blah, blah. This is basically you're telling the model what its role is. And then you're telling the model what its level of expertise is, right? In this case, I'm saying assume that you're an expert and your job is so-and-so. And here is your score template. So I'm giving it an objective, what its objective is at the end of this task, what it needs to do. So identify teams which have proposed feasible and meaningful integration, so on and so forth, right? And then pointers and validation points. I'm asking the model to validate if the idea that is being submitted, or the answer that is, in your case, let's say you want to build a validation system, has certain keywords, has certain areas that you want the student to focus on. Has given weightage to some of the topics that you want the student to focus on. So you can ask the model to see if the idea or the paper that has been submitted covers these things or has weightage for some of the areas that you want. And then the actual artifact. This is where I'm giving the score template. So score it in the following format. What is the ideation score? On a scale of 1 to 10, 1 being lowest and 10 being highest. Score them based on how good the idea is, how much it is aligned with the theme, and how much uniqueness and relevance it has to the problem statement, right? So I have a bunch of such criteria based on which I want the model to grade the response. But remember, don't try to ask the model to do math, right? Because that's not where it shines. We don't want the model to do any math. Don't ask it to sum the score and divide by do blah, 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 calculate the percentile. No. Don't do that. You can write normal programming or traditional programming for that. Just do language type or information-based questions or information-based prompt template criteria. Just add those to your prompt templates. And so in this case, this entire thing up to this.
Abby, can I just
Yeah.
stop you on that point? Because I think, we're in an analytics program here.
Mhm.
That dividing line between language and math,
Mhm.
things like running optimization code,
Mhm.
where is the line there? I mean, I understand basic arithmetic, but where is this line where it becomes math and where it becomes analytics?
So so what I'm saying is you can perform analytics with large language model, but you cannot expect it to do a complex calculation, unless you're using a multi-turn chat, in which case it will be able to do something. It will be able to it will be able to answer, talk back, and give you the response that you need. But it doesn't shine in calculations. Like it's not a you can't expect it to do a percentile calculation or do something that yeah, we cannot be doing that, because those are some of the things that you can do with traditional programming, right? There's nothing that you need there it's not a complex thing. It's not a time consuming problem or anything, which that's already solved. What we
So,
need is for it to be, yeah.
so are we using the prompt then as sort of a front end for the analytics tools out there? Is that how we should see it?
So
For
there are two
example,
things.
like creating some code that I could run on, for example, Gurobi, a Gurobi mathematical program, maybe a simulation model. I could auto create it in using the language model. Is that the way to think about this, for the analytics type use cases?
So I wouldn't entirely agree. So arithmetic problems and analytics are, I would say, they are two different things. You can perform analytics with large language models, but you can't do math. I'm not, when I say can't do, it's not a hard and fast thing, but I wouldn't expect continuous and consistent results unless I put a formula in there. Let's say I put a formula here. This is how you will calculate a percentage. You will have to give that information and say, this is a sample data, this is what happens behind the scenes. You have to tell that in detail and then ask the question. So arithmetic and analytics are two different things, right? For me, that kind of anything that's based on a formula or a calculation, I wouldn't expect large language model to do. But if it is analytics, for example, read this entire thing and take the sentiment, that is also analytics. Or take the one that's the closest to the one that the user is searching. Let's say I like this black color table, find all suitable chairs for it, or tell me how many chairs or how many colors are available for it. Picking that number from the database, or pick something that's available in the data, that it can do, which could still be analytics. So I wouldn't call it analytics. That's exactly what LLMs are for. You can do analytics, but you cannot do math. Cannot is something that I'm saying, it's not technically, it's not documented that you cannot do, but I wouldn't use that for mathematical purposes, like for performing calculations or something. Like I said, in this case, let's say I'm calculating those, I'm asking the machine to generate the model to generate score for each category: idea, potential, impact, technical aptness, feasibility, but I'm not asking it to sum all of these four. You
Fair
see
enough.
what I'm saying?
Yeah, I think I overused the word analytics. Yeah, thanks.
Yeah, yeah. So that's one thing. And then, yeah, so if you can see right here, this part up to line number 40 is pipeline or code prompt. From the point of line number 42 to 53, this is prompt as data. Why? Because this is exactly where I'll copy paste my students' idea or paper or response that they've submitted, right? This is what that's why it says end user prompt or data artifact. And then on top of that, I'm assigning or attaching PDF that the student has submitted. In addition to the idea text, I'm also submitting the video, the demos, and the presentation. So all that will come under this. So this part, line number 42 to 53, is prompt data, because this is dynamic. This is real time. You will not store this, because this comes in as part of your application front end. Everything else you have coded, right? So that's the difference. This one prompt, I just wanted to take a quick diversion there, because I remembered that I forgot to cover the most important part for prompt management. All right. Now moving on to fine tuning. Like I said, I promise that we'll see a sample overview of the steps involved in fine tuning. Extract and prepare data, code your model, train, tune, and evaluate, deploy, generate predictions, and monitor. So let's see these steps quickly. Notebook. Here's the notebook. There we go. Okay. So this is a sample collab.research.google.com notebook. Sorry, you can just open this and it resembles your Jupyter notebook. So you can just start writing your Python code in here. Model tuning with Vertex AI foundation model. So in this case, I've used the foundation model text Python 003 or 3, I think. But you can also do this with Gemini. What models support fine tuning is something you can get from the documentation and also from the model specific page in Vertex AI, which I showed you a few minutes ago. Right. So in this case, like I said, the use case is for a news channel to be able to summarize and get a headlines to generate a suitable title or headlines for the news body that has been created by their editors or their reporters. So that is the use case. So install dependencies just like you would do with any other application in Python, and then you import Vertex AI. You put your project ID because your project should be able to access these APIs, and then choose a region. Right. Moving further, all the imports and all the classes and all the methods and everything that you want to use. So make sure that you're aware of what classes you want to use from what package. So in this case, it's a text generation model, and we're also importing evaluation text summarization spec. You'll just see why in a bit. Okay, here, this is the JSON that I told you about, the train.jsonl. I've made this file also available, so you can actually take a look at this file when you're preparing or when you're trying this out on your own. The training data is also made available in a JSONL file. JSONL is nothing but JSON, but one per line. A line break after every JSON data is what JSONL file. So it has only two fields. It's very simple, input and output. This is my sample text chunk, and this is my headlines. So from historical data, right? So I don't know how much data. I think I have about 20,000 or something, but that's the training data that I've prepared. It is also publicly available in BigQuery. So I use the data that is licensed for, I mean, you could use for educational and non-commercial purposes. You could use the same data as well. So try it out. And then you can, so in this case, we are creating a data frame with the training data, right? This is what the data looks like. Like I said, this is the input text. The BBC News website takes a look at how games, blah, 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 the entire essay of it, and the output with just the headlines of the news, right? So how the fine tuning, if you notice, is just one line of code, right? Model. So what is the name of the model you want to provide? This is anything that you want the model to be named as. So this is the new model that you are creating by fine-tuning the existing model, text Python 002. This can be Gemini too if you want to, but make sure that the model that you want to tune is available for fine-tuning. The documentation link is also there in the blog. It's there in the slides as well, right? So text generation model, which we have imported from the Vertex AI package. So this is from pre-trained model text Python 002. So I'm just configuring this for fine tuning, and I'm choosing fine tune location as well, model tuning location. This could take several hours depending on the volume and the data that you're provisioning. So once the model tuning is complete, you will be able to print the response. As you can see here, this is a simple prediction that I've done for this chunk of data that I have for a sample data. This is the fine-tuned model response, which has created this kind of a headline. Shrinking space on planes, putting our health and safety in danger. This is a topic that your fine-tuned model has provided. But now let's take the base model and see. As you can see right here, I've used tuned model.predict. So tuned model is the model that we just tuned, that the variable holds it. How to call the tuned model at a much later point, you just have to get the endpoint ID and invoke the model. But if I want to see what the base model results for the same data, right? So I'm using the base model here, text Python 002 on the same data. And as you can see right here, if you notice, the response is not that different, but the style and the format and the voice, the tone of the headlines is slightly different. This looks, I like this one better, but this is not in line with BBC's traditional headlines style of data, right? So if you see, this is what BBC's news headlines look like. And once you've fine-tuned it, your response is also tuned from the model. Whereas without fine-tuning, this is what the base model or the foundation model responds as part of your prediction step. So look at this response. Shrinking space on planes, putting our health and safety and risk with a question mark. Choice of words, style of or formatting of the text itself, the punctuation and so on and so forth. These things are different. How different? I don't see it much different from each other, but there is subtle difference which uh, which which is making it very evident that using fine-tuned model will apply more for your application and for your business use case rather than using the foundation model as it is, if it is of concern to you. Because you cannot expect a news channel like BBC or anything for that matter to use to use headlines that's generated randomly, right? They might want to use their own specified format. So that is where this kind of use case will come into help. Now, do you have to fine tune your model always? This is a question I get asked in most occasions by developers and startups as well. Not necessary. If the That's why we do prototyping. That's why you go to Vertex AI Studio, which we saw before, and do a bunch of tests, do a bunch of prototypes, see how it responds to your data, see how it responds to your users. If you feel that the response from the foundation model is good enough for you, you don't have to fine tune it. But fine tuning is typically suited for business scenarios where you need your model response to be in alignment with some style that is part of your business itself. Now, without fine tuning, how can I ensure the responses are not wild and creative and random? So that is where you need to think about RAG, using frameworks to implement RAG. So we are not covering RAG as part of today's session, but I'll just give an overview. RAG, it stands for Retrieval Augmented Generation. It means you provide a context. Like in the case of the prompt template, I told you, right? I gave a big context as to what to compare it against, right? Or gave a big context of what form, when I say formula, what template it has to use to compare and score the results or the submissions, right? So that is what we call as augmentation, giving more data from either your repository, either from a database, or from some other PDF that's available that you're entitled to use, right? So giving that kind of a data augmentation is what we call as context. So retrieval augmented generation means you are using that context that you provide from an external source or from within the source as extra information for the model to read and understand and generate responses from. If you go to one of my blogs on Medium, I've written a blog where it just takes up you just upload a picture of yourself or anyone who needs a hairstyle recommendation. It just references some publicly available PDF that I use for test purposes. And it has some material from all over the internet. It also has some material around face shapes. And it compares that face shapes along with the picture that you uploaded. It compares that against that, and also takes the information that's available in PDF and matches and suggests the right or not right, but recommends the one that the model thinks suits your face. Now, that's the haircut I got a few weeks ago. It's grown out of it, so don't judge the model for the haircut that I have right now. I've just messed it up right now, but yeah. So that's one of the things I did. So you can learn how to do it. So that is a RAG, right? Retrieval augmented generation. I have not fine-tuned the model to do anything differently, but I have given it additional information to get the response for me, so that it's not picking out some random styles, rather sticks to an expert hairstylist, right? Who's ever was there in internet that I picked from. So that's
Abhi,
exactly.
just a quick sort of maybe a naive characterization of RAGs and tunings. RAGs would be local context, maybe data that's relevant to the firm, to the use case, and tunings would be sort of more of a style kind of question. Would that be fair? Like, getting the output to come in a style that's consistent with, let's say, the BBC or the Queen's English or something like that. Would that be a fair characterization of RAGs versus tunings?
You can say that, but I wouldn't categorize it and assign that kind of a terminology for a style as a terminology for fine tuning. The reason is sometimes you might not have additional information, but you may have data historically, and you might be able to fabricate a story and make it as available as augmentation instead of fine tuning the model itself. You can actually use it interchangeably, but fine tuning is more of when there are two ways to fine tune. I think that's where the confusion. Sorry, I only talked to you about supervised learning. There's also another kind, which is human feedback reinforcement learning based training as well, where you get the response and you thumbs up You ask the user to thumbs up or thumbs down and provide comments as to whether or not the response is okay and what can be different with the response. So based on that, also you can tune. So tuning has its own purpose, but definitely when you have a bunch of text or videos or material that you can provide as grounding information, that's when we go with RAG. You can do both. It's not like you have to choose one or the other. You can definitely choose to do both. You can fine tune a version of the model and use it for your purpose as well. There's also another thing here called model distillation, apart from fine tuning. So this is where you distill the model to work for a specific subset of the data rather than having the entire model fine tuned and deployed for your purpose. You can just make it work for a smaller subset, and which is also efficient in terms of cost, in terms of the scale of data that you're looking to solve as well. So model distillation is another option. You can also do that from Vertex AI console as well. So I wouldn't use it. I wouldn't use the word style only, but it can be for context purposes also. I know of startups which have chosen the method of fine tuning for business specific information. Let's say you have tabular data and you just want to convert that into JSON-L, and you want to programmatically fine tune the model without having to use that as a augmentation, data context augmentation. You can still use it, call it fine tuning, right? So yeah, you can contextually you can fine tune for contextual purposes as well. I wouldn't classify it just for text, but yes, in our use case, we use it for more of a style purpose. But maybe the example that I took to predict was not too different. But let's say there's another piece of news where the responses are too alarmingly different. Like one is using some words that are not okay for BBC, right? So in which case, fine tuning will go to a certain extent of controlling the response with the words that BBC, the news channel typically picks. But if I do a RAG, or if I do grounding, or if I do the prompt template prompt template standardization, which we saw before, where I say do not use words like this, right? So if you go to the Vertex AI configuration, the prompt configuration page where we saw temperature, top P, top K, there is also advanced parameter configuration where you can put words or combination of words that you don't want the model to respond with. So that is also something you can configure. So there's a lot of ways to address this, Graham. So your answer is not wrong. It's definitely one way. It is also one of the things that you can solve with fine tuning, but I wouldn't limit it to that.
Thanks.
Yeah. Lastly, like I said, there's one last topic which I wanted to cover. I'll just quickly wrap it up. I'll talk about it more than I'll probably give you links and placeholders which you can do it or try it out on your own, which is integration with enterprise data. So let me just quickly go over there. Yeah, connection or integration with enterprise data. So far we saw how we brought prompt management, how we brought LLMs and other things to your data. But we didn't see it in the context of database or in the context of where your data is stored itself, because ultimately that is important. Database is there to stay. We need to store the data in order to do anything on top of that, right? So that is where in-place LLM with Google Cloud databases, or any database for that matter, where if you're able to do in-place LLM, there's nothing like it. The reason is, more often than not, you don't have you have analysts, you have analytics teams, you have data scientists, but not all of them can program in all programming languages that support all libraries for a specific model, right? So some folks who are the data analysts, who know so much about the data, who know so much, who make the business decisions, they can write queries, but they are not necessarily able to write programs that use APIs and libraries, client libraries, and deploy them and all, right? So that's where you want to be able to make them feel empowered, or make them write their own applications in SQL or wherever your data is stored. In the case of structured data, it's SQL. In the case of semi-structured data, you probably have some quick calls or procedure calls. When I say procedure calls, quick methods, remote methods, functions that you can call right from the data itself that will perform LLMs on the data without them having to leave the database, or basically bringing LLMs to databases is one thing that I always talk about also. So this is something you can refer this code lab for. The QR code will take you to the blog and then to the code lab or repository as well. So all Google Cloud databases like Cloud SQL, Firestore, AlloyDB. The most high performant of all is what I would think when it comes to real-time streaming data and all that. Spanner and BigQuery, all of these databases and data warehouse in the case of BigQuery, they're all empowered to support Vertex AI's large language models from within the scope of data. So how simple is that? Just by using context like ml.generate text off. I can show you this right here in this. I have it open and ready to just showcase this. Oh, wait a minute, just a second. I had the database open. Let me just quickly. Oh, where did it go? Okay, sorry, it's right here. Sorry about that. As you can see right here, it's able to bring in the case of, let's say, I told you about embeddings, right? Converts text in any form or data in any modality. In this case, text, I've used text into embeddings. So let's say you want your data to be converted to embeddings in a specific table in this database, Spanner Cloud database Spanner, right? So all I had to do was just use the remote function ml.predict. That's it. And the model that I've passed here is text underscore embeddings. But I've created this as a remote model already with just one DDL, which is a data definition language. It's a create or replace model text embeddings. And then I'm connecting that particular model to Vertex AI's embeddings model, which is made available for text. So I'm calling Vertex AI from right within the scope of data, which is Spanner, by just defining this text underscore embeddings model. This is a custom model which I've defined already, and I'm just using it in a select SQL, just like I'll use any remote procedure from your database queries. It's as simple as that. So this allows you to convert your data then and there, right in its place, into embeddings. It's not just limited to embeddings. You can do cosine similarity, which is vector search. You can also do other, not just cosine similarity, any other distance method that you would want to use. Basically, vector search can be done from within the database. You can call Gemini, you can call text Bison, you can call all LLM Vertex AI APIs or models from within the scope of data. That is something I wanted to say as part of enterprise data integrations. Also, another thing is if you're using BigQuery for both structured and unstructured or even semi-structured data, you will be able to bring in the value of generative AI or the large language model to both your structured data, which is the tabular data, in association with unstructured data. So how does that work? BigQuery is able to reference images or any other unstructured data that is stored in cloud storage directly as in the form of external tables from within BigQuery itself. And you can join that table to your tabular table, and you're able to call the Vertex AI generative AI models from within BigQuery just by using ML Predict. So basically, you can bring all formats of data together and query on top of them. There is a blog that I've written on that topic as well. So for further reading, you can use that as reference as well. This is there in the slides, which I'll share with Graham. So you'll have access to all of these things. Sorry, this is like, I know it's a lot of information. I just wanted to cover these topics. So even if it piques your interest a little bit, you can go and learn about these topics in advance at your own time. That's what I wanted to do.
Awesome.
So that's pretty much it. Now for some, yeah, I'll just give them the credits in case you want to try out hands-on anything that we discussed today. This is a $1 credit that you will get if you just use this link. So you can copy this. Don't access it from your mobile phones, access it from your laptops. So, and also use your personal Gmail account. So that way you're not restricted to use any project or something. Use the Activate billing account with this. You don't have to use credit card or anything to create a new billing account. You'll just click this link and follow the steps it tells you. It's pretty straightforward. So you can get started and try out some of the things we discussed today. It's trygcp.dev/ oh, sorry, it's not events, it's E. Apologies. trygcp.dev/e/cv-s6.
Very cool.
Yeah. And if you'd like to learn more sessions like this, codevipassana.dev is a set of instructor-led hands-on sessions. It's also coming to North America soon, later this month. So look out for this. You can sign up in advance if you like in the site. That's about it.
Could we do
Thanks
some?
for the
Could we do some questions, Abhi?
Yes. Yeah, sure.
Questions, folks? So this was intense, all right? This is not a Gen AI course. Any thoughts or questions here? Yeah.
I'm just curious about the like cost structure of this. So if you're a business that wants to apply this, like how affordable is it? You know, like if you're like a travel agency that wants to build a GPT for a chatbot to communicate with people planning trips, right? Is this something that's like affordable for small businesses or small, medium-sized businesses, or not really? Like, how does the cost structure work? Is it a monthly fee through GPT? Is it by credits, like the amount of text that's output by these models that you develop, or what?
So building an application, it has a lot of components that go into it. So what are the other components that the business is choosing to use to build that entire architecture will determine the overall cost of the entire application that you just explained. So just taking all of that into account and leaving everything else but the generative AI component, the let's call it Gemini for now, because let's say they are using Gemini for this chatbot, right? So if they're just taking that particular model into if we are just taking that particular model into account for cost analysis, definitely it's not just about, it's not a monthly fee, it's not like that. There are ways you can configure your cost model for yourself in a certain way. You can work with the businesses can work with the sales teams to see what works best for them. But in a generic scenario, I think it's tokens based, like how many responses or how many requests are made to the API or the model itself. That's what determines the cost. Of course, there are people. So I know of startups who are still scrambling around and using large language models more than once for one use, like one particular interaction, which is not required. They can optimize the number of calls that they are making to the generative AI model. They can optimize it, they can do a lot of things in a traditional programming way, and on top of that use generative AI only for when it's absolutely required. But that's not being 100% clear in all the scenarios. But yes, those are the things that small business need to take into account, how to optimize the calls made to generative AI. But at the same time, to answer your question, yes, it's based on the number of requests and the number of tokens generated in response. The cost is determined based on that. There's a price calculator that gives the detailed picture about the cost per token, or how much, what is the cost based on the number of tokens that's written in the documentation.
I think your question is sort of heading in the direction of there's going to be some use cases where the Gen AI is natural and the way to go, and then others maybe more calculation intensive that are maybe not a good match here, right? I don't know if you could hear that, Avi.
Come again?
I just said that, taking Anatol's question, there's going to be some use cases where Gen AI is going to be a good fit because of the cost structure, and others where, maybe more calculation intensive use cases or more structured use cases where maybe not.
Yeah, I can give you an example. Like recently I was working with a startup. So they are just, let's say, I don't want to say exactly what they are trying to evaluate. Let's say they are evaluating a structure of information against something else, right? So contextually, the contextual comparison is something that generative AI can shine at, right? Because that's what we are manually good at doing. If you compare two answers, you're able to manually compare and validate those two and say, oh, this is closer to the baseline than something else, or this actually stands out as a better performance than the other. So you can manually do that with human brain. But whereas programming it is slightly difficult. That's where large language models come into play, and you can use Gemini or a large language model to do this kind of activity. But instead, the startup, what they were doing is they did not just use it for this particular purpose. They were, of course, using it for this as well. But in addition, they were using LLM to do, spell check, grammar check, So they were totally making 5 calls. I would be like, why would you want to use Gen AI to do things that are already that have Python libraries available, right? There have libraries available in other languages for. So don't use it. Cut your cost. Use it only for where you need generative AI. Only like think about this: where human brain shines the most, and you think LLMs can do a good job at it than traditional, programming, systemic programming. Use LLMs for that. For other purposes, if you have libraries, use them. Those that are free, and if cost wise, it's differentiating. So that's something that I would recommend.
Questions, folks? So I've got a question for you. One of the things that I'm mulling is, especially from a teaching perspective, committing to the Google ecosystem or the Amazon ecosystem, it seems that these spaces are becoming more and more democratized. And I don't have to get too deep in before I'm able to pull out if I feel like, okay, one of you are pulling ahead of the others. What are your thoughts about this? I mean, your ecosystem looks pretty massive from that historical evolution slide. What are your thoughts about how democratized Gen AI is right now?
There are some open source models, I would say. So, or not open sourced, but open models, I would say. So I think from where we started, we are still only 2 years into it, I think. So for just a little over 1.5 years, I think it's pretty huge. The amount of reach and the democratization that it has seen is pretty huge. But I think 2 years down the line further, the reach will be even bigger. The democratization that the perspective that you're talking about will be even bigger, and a lot of things that seem that seem very complex or seem very not tedious is not the right word, because it's anything but tedious, but it simplifies a lot of things. But some of the things that look more sophisticated right now will look very simple. It'll be like an everyday thing, not just for software people, but also people from other industries or folks who are focused on business rather than technology. So it'll become everyday household thing. Like everyone talks about generative AI, and it's not just data scientists anymore, right? At one point it was AI, these things like summarization, but Bert, I use this example way too often because I used to use Bert, and at that point it was a big deal when I say I use Bert to do something, to summarize, and folks from business teams thought that was a big accomplishment. This was like 5 to 7 years ago. It was like, oh, okay, so you were able to summarize this. Oh my God, it saves so much of our work. I was like, it's just an API call behind the scenes, but yeah, okay, I understand what you're saying. But now, I mean, business teams are way ahead of technologists here, because they are hungry for things that simplify their job and things that get them more return of their more impact for their business. So yeah.
Bigger and bigger models, or more tailored use case, vertical specific models? Where do you see that going?
I think both. They're growing in both directions for sure. Particularly with respect to Google Cloud, I would say, because we have some Google Cloud. Like if you see, every area wants to, when we even when we talk about DevOps engineers or SREs, everyone wants to incorporate generative AI in their domain, right? So when it comes to even different domains of software delivery, we're talking about generative AI. Then industries, I mean, it's only fair that they ask for generative AI in every aspect, right? So we have some Google Cloud healthcare APIs. We have Google Cloud retail APIs. So those things are also there as part of the Google Cloud suite, which are not spoken about much. Like in as a developer forum, we like I don't conduct a developer hands-on session and talk about healthcare API, because you can't expect all developers to be from one domain. They'll be from diverse backgrounds, so I cannot be talking about healthcare API. But there is a huge demand in a healthcare conference for that matter. I can only talk about Google Cloud Healthcare API there. So there, the ask is about how can I use generative AI in this particular domain for this particular use case. They are even going within that vertical. They are going into specific domains. So yes, I think it has to grow in both ways. It will grow in both ways. That's what I think.
Last question, folks. Anybody online got a question? Abby, really appreciate this. Thank you so much. We'll get the recording up and then the views. We've got some applause in the background here.
Thank you. I'm so sorry for making it too heavy. I just wanted to talk about everything just in case if it triggers your interest, you have something to think about. That's
We're going to have a lot of resources, and after the finals week next week, I think we'll have some time to process all this. Really appreciate it. Thanks so much. Enjoy your evening. You're in Istanbul, right?
Yeah, I'm in Istanbul.
Yeah. Have a good night. Enjoy.
Thank
Thanks.
you. Bye.
Bye.